All right, so same as the ones we were working on yesterday. Okay, I just want the reaction type. Okay, so like synthesis, single replacement, combustion, whatever. I want it written out in words, and I want it balanced. All right, so there's 5 here. All right, so if you guys can get going on those, let's see how we do it. In a few minutes, I'll go through the first one. A few minutes later, I'll go after the second one. Okay, and so on. Let's see how we do. Okay, let's look at the first one here, guys. So for number 1, I've got a single compound, and then on the product side, I have 2 elements. So what am I looking at for a reaction type there? That's a decomposition reaction, yeah. Okay. Okay, and if I want to write this out in words, this is a molecular compound, so I'm going to need my prefixes. This will be trinitrogen dioxide, okay, and that is going to break down into, do I change the names of these? No, I just write their element names because that's what they are, nitrogen plus oxygen. Okay, what should I balance first? The largest number, which is nitrogen. It's a 3. So on the reactant side, it's a 3, but on the product side, it's a 2. So how am I going to get those to balance out? 6, yeah. The lowest common multiple is 6. So 2 times 3 is 6. 3 times 2 is 6. Now I got to go back and check my oxygens. 2 times 2 oxygens is 4. 2 times 2 oxygens is 4. Now I've got it balanced on both sides. Okay. How many people have done the second one? Okay, let's look at the second one too then. Okay, what kind of reaction am I looking at? I got an element reacting with an ionic compound producing a different element, a different ionic compound.
Single replacement.
Single replacement reaction. Okay, writing this thing out in words. That stuff is calcium. This stuff needs a Roman numeral in its name. Okay, because iron has more than one possible charge. It can be a 2 or a 3. So chlorine's always a -1, so I've got 3 negatives. Okay, so I got to get 3 positives from that single iron. So this is the iron that is 3 plus. Iron 3 chloride. Okay, what is that stuff? Iron. Do I need to put a Roman numeral beside it? No, I don't. Okay, not when it's by itself. It doesn't have a charge when it's by itself. I only have to indicate what charge it has when it's in a compound and actually has a charge. Here, it's an element. Its electrons and protons are balanced. So I just have to write iron. Okay, and then this stuff here is calcium chloride. Okay, there's only one thing out of balance right now. What is it? Right now, there's 1 iron on both sides, but the thing iron's attached to is out of balance. Chlorine. Yeah, chlorine is out of balance, right? There's 3 chlorines on this side and 2 on that side. So just like the last one, the lowest common multiple is 6. So 2 times 3 is 6. 3 times 2 is 6. Putting this 2 here also affects my iron, so I've got to put a 2 there. Putting this 3 here affects my calcium as well, so I've got to go back over here and put a 3 in front of the calcium. Now the whole thing is balanced. Hey, is that ringing a bell? All right, I'll give you a little bit of time to get ahead of me. Number 3 is going to be a bit more challenging on the balancing part. So on number 3, we've got a hydrocarbon. So molecular compound containing carbon and hydrogen reacting with oxygen to produce carbon dioxide and water. What kind of reaction are we looking at? It's a combustion reaction, exactly. Okay, now combustion reactions obviously have their own set of rules when it comes to balancing. Rule number 1, I balance alphabetically. Rule number 2, if I have an even number of carbons, I start my balancing with a 2. Does this have an even number of carbons? It does. Okay, so that means I gotta put a 2 right at the front of the reaction. Okay, so how many carbons do I have? 12. Okay, I'm seeing everybody like write down the 2 there. Do I need to go through why we need to use the 2? Okay, if I don't put a 2 here, what's going to happen is I'm going to get a decimal somewhere in my balancing. And according to Dalton's atomic theory, we can't have half of something. We can't have half an atom or half a molecule. Okay, it has to be a full thing. All right, and that's what's going to happen here. So if I don't put a 2 there, and I start with 6, and I put a 6 here, and I have 14 of these, and I put a 7 here, okay, and now I do my oxygens. I go 6 times 2 is 12, plus 7 more is 19. What's 19 divided by 2? 9.5. Can I have 9.5 oxygens? Nope. Okay, that's why I start with a 2, because it'll double everything. And then I won't end up with a decimal. Okay, because I can't have a decimal when I'm balancing a chemical reaction. Right, so that's the reason we put 2's in only for even numbers. Because it doesn't happen with odd numbers. If I have an odd number of carbons, that doesn't happen. But if I have an even number of carbons, it does. So if I have an even number of carbons, I start with a 2. Now, 2 times 6 is 12. So I put a 12 here. Okay, 2 times 14 is 28. Okay, 14 times 2 is 28. Now I can balance my oxygens. I have 24 oxygens here, 12 times 2, plus 14 more is 38. 38 divided by 2 is 19. Okay? Everybody all right with that? Okay? So yes, do we get some big numbers? We do. But we don't get any decimals, and that's important. Okay, if I'm writing this thing out in words, I don't know what the prefix is for 14. Okay, I don't know it off the top of my head. Okay, but this stuff here is hexane. I would not give you one on a test that you could not do with the prefixes up to 10. All right, so you won't get one like this on a test. You can use the prefixes up to 10. This stuff is called hexane, okay, and it's reacting with oxygen and producing carbon dioxide and water. Okay, so yeah, the balancing for combustion is a little bit tricky, okay, but it's always the same rules. So if we follow those rules, we can't really go wrong. Questions on 3? How many people have done 4? Okay, let's look at 4 as well. All right, so on number 4, okay, I've got an element reacting with an element to form a compound. What kind of reaction is that?
Synthesis.
Synthesis. All right, written out in words, Cl is chlorine, and that's how chlorine looks as an element. It's reacting with lithium, and that's going to produce lithium chloride. Okay, in the reactants, chlorine came first. Why didn't I write chlorine first on the product side? Okay.
Because it's not a solid, or not, because it's molecular.
Right, it's a non-metal. Yeah, and so I made an ionic compound, and in an ionic compound, I have to list the metal first. If I do this on a test, when we get to predicting the products of a chemical reaction, and I've done this, I only have so many tricks in the bag, okay? I write it like this. You'd be surprised how many people will write CLLI on that side, because they don't think about it. They forget. It's like, oh, well, I'll just put them together. It's a synthesis reaction. They just go together. They go together, but they make an ionic compound, and I gotta write the metal first, okay? And that's just me checking if you remember that little detail. All right, now we got to balance it. Only thing out of balance is chlorine. There's 2 on this side. How many over here? 1. So what needs to go here? 2. Okay, does that affect my lithium?
Yep.
Is it good now? Okay. How many people have done 5? Okay. Let's do 5, and then we'll have a look at these other ones that go the other way, because we ended off yesterday talking about going from words to formulas. Okay, so for this one here, we got an ionic compound reacting with an ionic compound, making 2 different ionic compounds. What kind of reaction is that? Noah, what kind of reaction is that?
Compound on each side,
Yeah.
that's double replacement.
Double replacement, you got it. Okay, so we got a double replacement reaction. If we're writing that out in words, this stuff here is magnesium fluoride. And that is reacting with cobalt nitrate, but cobalt has more than one possible charge, so that's going to need a Roman numeral. All right, nitrate's a -1. There are 3 nitrates, so that's 3 negatives. So this is the cobalt with the 3 positive charge, because there's only one of them there. So cobalt 3 nitrate is going to give me magnesium nitrate. And cobalt fluoride. Do I need to do that whole process again to figure out the Roman numeral? The answer is no, I don't. If I started out with cobalt 3, that's what I'm going to end with. Otherwise, I'd be creating a new substance, and that's not what's going to happen here. So the good news is you don't have to do that twice. If you figured it out on the reactant side, it's the same one on the product side. Okay. All right. You have some reactions here now that go, oh, sorry, did we balance it? We forgot to balance it. I forgot to balance it. All right, what should I start with? What's the biggest number?
3.
3, and that's on nitrate and fluorine. Does it matter which one I pick? Doesn't make any difference. All right, I'm going to start with fluorine just because it's first. Okay, there's 2 on this side, there's 3 on that side, so I'll make 6. All right, when I put these 2's here, they apply to the other thing, so 2 cobalts, so I got to go back over here and make sure I have 2 cobalts, make sure I have 3 magnesiums, and then I'll double check my nitrates. 2 times 3 is 6, 3 times 2 is 6, and 2 times 3, 3 times 2, yep, looks like everything checks out. Okay, all right. Now, you're going from word to formula, which is trickier, because you got to remember some things. If you make an ionic compound, what do you need to do with it? Drop and swap. What are the special elements? We got to remember that too. If we make a special element in a reaction, or have a special element in a reaction, we got to make sure we put the right number beside it if it's by itself. Okay. You guys can try those. I'll let you get a bit ahead of me here, okay, and then we'll go through. just made some extra ones up, so no, these ones aren't. The ones we did at the end of the day yesterday. Okay, let's have a look at number 6. Oh, I was recording all at dead time. Oh, well. Okay, so for our first one here, okay, we've got copper 2 nitrate. So if we get it in words like this, then we got to lay it out in formula form. So copper 2, right? So I do what I would normally do in writing the formulas. I write the symbol for the metal. I write its charge. The Roman numeral tells me what its charge is. Okay, nitrate is NO3, and that's a -1. So when I drop and swap, I'm going to need brackets around the nitrate with a 2 outside. Okay, reacts with magnesium. Magnesium's by itself here. It doesn't say it's in a compound with anything. Right? And that's going to form, so anytime you see to form or produce or something like that, that means that's where the arrow goes. Okay? Magnesium nitrate, so okay, magnesium is a +2, okay, and it's with nitrate, which is a -1. So we got to do the same thing here. We're going to have brackets and a 2 outside of the brackets, and copper. All right, so I think I've dropped and swapped everything correctly, so I don't have to worry about any of that, and that's important because if I don't swap and drop something, then it won't balance correctly. Okay, and I don't have any special elements. Copper isn't special, it doesn't come as a 2, so I've kind of double checked that. Okay, now I need to identify what kind of reaction that is.
Single replacement.
Single replacement. I got ionic compound reacting with an element, okay, forming different compound, different elements. So, single replacement. Okay, now I got to balance it. Good. Because everything's already balanced in that one. Okay, there's 1 copper on both sides, there's 2 nitrates on both sides, there's 1 magnesium on both sides, we're good. Okay, questions on number 6? Okay, how are we doing on number 7? How many people have done number 7? Okay, I'll give you a couple minutes on that one, maybe 1 more minute, and then we'll walk through that one. It's the balancing that's obviously tricky on that one. Okay? All right, let's look at number 7. So they tell us what the compound is because I have no idea what the prefixes for 12 or 26 are. Okay, and that's usually what will happen if I give you one like this that's beyond the prefixes we know, I'll just give you the compound. Okay, so C12, H26, okay, reacts with oxygen gas. What does that look like? O2, so there's a special element we got to be wary of. Okay, and that's going to produce carbon dioxide, so 1 carbon, 2 oxygens, and water. In a combustion reaction, we want to write that as H2O. Okay, what kind of reaction is that? I just gave it away. It's a combustion reaction, okay? Because we have a hydrocarbon, okay, reacting with oxygen, okay, making carbon dioxide and water. All right, do I need both balancing rules for this one? Like, do I need the rule of 2? I do. 12 is an even number, okay, so I need to start with a 2 here. Okay, so what's 2 times 12? 24. All right, we're going to get some big numbers here, okay? And 2 times 26 is 52. And 26 times 2 is 52. Okay? By the way, that's a pattern you can count on in these reactions generally. Okay? That this number is the one that will go there. Now I can do the oxygens. So I've got 26 oxygens here plus 48 oxygens here. Okay, which should give me 48 and 26, 68, 74. Yeah, okay. All right, see this, I do math in my head, which is bad, I shouldn't. All right, so I need 74 oxygen. 74 divided by 2 should give me 38? 36. No, 38. That was right the first time.
37.
37. See, this is why I shouldn't do math in my head. Okay, 37. I should just, start the calculator and do it that way. Okay, big numbers, yes. Okay, can you have a calculator on your test? Yes. Okay, you can totally have a calculator. All right. Give you a few more minutes to do 8, 9, and surprise, 10. Okay. Okay, let's have a look at number 8. So we got lithium nitride, which sounds like an ionic compound to me. So lithium is a +1, nitride is nitrogen, it's a -3. So when I drop and swap, I'm going to get Li3N. Okay, and it says it breaks down, so it's not reacting with anything. We just got an arrow. Okay, into nitrogen and lithium. Anything I need to check for?
Is nitrogen a special one?
Nitrogen is a special element, and I need to check that. Is lithium special? It's not. Poor lithium. Nobody likes it. Okay, all right. So now that we've got that, now we can look at balancing. Here's another situation where using the biggest number doesn't work. Okay, and the reason it doesn't work here is because lithium only has a charge of 1. Nitrogen has a charge of -3, and there's 2 of them over here. So it has a bigger effect on how the reaction works out than lithium does. So if I just balance the lithium, I'm going to go right back over here to change the number in a minute. Right? So I'm just going to start with nitrogen. Okay, so there's 2 nitrogens on this side, so I'm going to put a 2 here. That's going to give me how many lithium? 6. Am I good now? Yeah. Okay, how many people have done number 9? Okay. So for number 9, all right, so for number 9, okay, we've got hydrogen sulfide, so H with S. This is a +1, and that's a -2, so H2S. Okay, reacts with calcium hydroxide. Okay, that's a 2+, hydroxide is a -1, so when I drop and swap that, I'm going to get that. And that's going to produce calcium sulfide. Okay, is that compound okay? And water. Alright, in this one I'm writing water as HOH, because it's easier to track where the parts come from for balancing that way. Okay, what kind of reaction am I looking at? Double replacement. Okay, so I got DR for this one. Okay, and what should I balance first? Hydrogen, yeah. I mean, or I could balance hydroxide too, they go together, but hydrogen's first, it's a 2, it's the biggest number. Okay, so there's 2 hydrogens on this side. Now there are 2 hydrogens on this side. That also gives me 2 hydroxides, and there's 2 hydroxides over here, so that's good. Okay, there's 1 sulfur here, 1 sulfur here, 1 calcium here, 1 calcium here. Looks like we're good. Okay. How many people have done the last one? Okay. So for number 10, I got phosphorus. Is it special? Very. Comes as a 4. Okay, P4. Reacts with oxygen. Also special. Not as special. It's only a 2. Okay, to produce triphosphorus dioxide. Okay, I don't have to swap and drop anything there. Okay, I've got it set up the right way. What kind of reaction am I looking at? Sean, what kind of reaction am I looking at? Opposite. Synthesis, yeah. Okay, putting them together. Decomp's breaking them apart. Okay, so we got synthesis reaction, and now I need to balance it. What should I balance first? Emily, what should I balance first? Phosphorus, right. Okay, it's the biggest number. So there's 4 phosphorus on this side, and there's 3 over here. What's the lowest common multiple? 12, yeah. All right, so I'm going to put a 3 here. 3 times 4 is 12. I'm going to put a 4 here. 4 times 3 is 12. Okay, those are balanced. Now I need to look at my oxygens. 4 times 2 is? Should be good now. All right, we are looking at 103. Okay, let's take a 5-minute break within the classroom here, and then we'll start looking at some other ones here. But they all work generally the same. Okay, it's always the same set of steps. Okay, so for number 7, we've got copper as a metal. Okay, reacting with sodium chloride, ionic compound. Okay, producing copper chloride, but it's going to need a Roman numeral, and sodium. All right, so I got to get the Roman numeral in here for chlorine, or sorry, for copper. So chlorine is a -1. Okay, so that gives me -2 on this side. Okay, and so this copper has to be the +2 copper, so Roman numeral 2. So that's what it should look like written out in words. Okay, and for the balancing, the only thing that's out of balance right now is the copper. There's 2 on the product side. Putting a 2 here fixes that, but it gives me 2 sodiums, so I need to put a 2 there, and now the reaction is balanced. Okay, and it is a single replacement reaction. All right, now number 8. How many people have got it written out, but just can't make it balance? Okay, that's kind of what I thought. All right, it's a tricky balance. Let's do the other 2 parts first. So, looking at the type here, I got 2 things combining to form only one thing. What pattern does that generally look like? It's a synthesis reaction. Anytime you only have one product, it's a synthesis reaction. Okay? This isn't a true synthesis reaction where we have only 2 elements coming to form a compound, but we have 2 materials forming a single compound. All right, when we're writing that out, this stuff here is sulfur dioxide, okay, because it's molecular, reacting with oxygen to form sulfur trioxide. Okay, so that's what that should look like written out in words. Now, the trick with this one is that oxygen is in every single part of this reaction. So remember that when we're balancing, what we're trying to do is make sure that there's the same number of oxygen atoms, in this case, on the reactant's side as the product side. Okay, so on the reactant side right now, I have 2 and 2 is 4 oxygens. How many do I have on the product side? 3. What's the lowest common multiple of 4 and 3? 12. Okay, so on this side, if I wanted to get 12 oxygens on the product side, what would I need to put in front of this? 4. A 4. Okay, when I put that 4 there, it gives me 4 sulfur. So I'm going to go back, and before I do anything else, I'm going to make sure my sulfur balance. Okay, now I have 4 sulfur. I'm okay with that? But I also have 8 oxygens there. But I still need 4 more, because I have 12 on the other side. So what in front of this will give me 4 oxygens? Okay, now, am I done? It's balanced. But what can I do to those numbers?
Reduce.
I can simplify, yeah, I can reduce. Okay, the correct balancing for this reaction is 2, 1, 2. Okay, because these can all be divided by 2. Right? The reason for that is, yes, we decided that the lowest common multiple was 12, and it is, but there's actually a lower form that actually makes this reaction balance. Okay? So if that happens and you can reduce it, you should. All right, I'll give you a couple minutes on number 10. Okay? It's a similar type of balancing thing, but not as bad. Okay, so for number 10 here, okay, I've got nitrogen reacting with oxygen. Okay, so I got 2 elements combining to form dinitrogen monoxide. Okay, what kind of reaction is that? It's a synthesis reaction. Okay, and I need to balance it. Looks like the nitrogen's already good, but the oxygen isn't. There's 2 on the reactant side, only 1 on the product side. So what needs to go in front of dinitrogen monoxide? A 2. Yeah. Right, and when I do that, that gives me 4 nitrogens. Now I've got 4 nitrogens over there, and now it's balanced. Okay. All right, before I put up the ones that are going from words, we're gonna do 3 more, but they're going from words to formulas. So I marked your labs and I've returned them to you if they were done. Okay, for those of you that did not submit them because they are not finished, I would like them by tomorrow. If I do not have them by tomorrow, then I will start looking for you to get them done. That would mean that you have to hang out with me, and that's not cool for you. That's not really cool for anybody, but okay, if it doesn't apply to you, okay, get that done. Okay, I don't want to have to hunt anybody down and have them stay here to get their work finished. Okay, so please get those done for tomorrow. Okay, because I'm going to be going through them with everybody tomorrow. Okay, and I would much rather have yours in before I do that. Because after I do that, I just don't know how much of it you knew and how much of it you were just able to sit there and copy down. Okay, fair enough? All right, I would like you guys to do 7, 8, and 9. All right, let's have a look at 7 here, and maybe 8 if we can. All right, so on number 7, we got calcium oxide. So that's an ionic compound, so Ca, which is a 2+, with oxygen, which is a 2-. So that compound is good that way. And magnesium chloride, MgCl, that's a 2+, that's a 1-. So when I drop and swap, that's what that should look like. Okay, they react and they produce magnesium oxide. Okay, +2, -2, so that one's good the way it's written. And calcium chloride, CaCl, that's a 2+, that's a 1-. So when we drop and swap, we should end up with that. Okay, what kind of reaction are we looking at there? Double replacement reaction, yep. Okay, looks like it's already balanced. I think we're good there. All right, and let's look at number 8, and then we'll call it a day here. Okay, how many people have done 9? Oh, okay, let's do more. Okay, hydrogen iodide. So H with I. If H is listed first, it's an ionic compound. That's a +1, that's a -1, so that one's good. Okay, and it reacts with oxygen, which is a special element, and we can't forget that. Okay, and it's going to produce iodine, which is also a special element, and water. Right, I'm going to write it like that simply because, well, that's the easiest way to track where everything goes. I didn't have an OH in this one. Okay, so what kind of reaction am I looking at? It's a single replacement reaction, ionic compound reacting with an element. Okay, and for balancing wise, I've got 2 hydrogen over here. It's my biggest number. Oxygen's also a 2. Okay, so I'll probably put a 2 in front of this. That's going to balance both my oxygen, and then it's going to balance my oxygen. Then I'm going to come over here and make sure I've got 4 hydrogens. That gives me 4 iodines, so I need a 2 there, and I think that does it. Okay, that should balance everything on that one. All right, and our last one, okay, we got magnesium as an element, reacts with nitrogen as an element, okay, to produce magnesium nitride. +2, -3, so we're looking at Mg3N2. Synthesis reaction, and it's balanced. Okay? What we're going to start looking at soon is being able to predict the products of a chemical reaction. All right, so I only give you the reactants. You have to figure out what the products will be. All right, tomorrow, Thursday, you have a quiz. There'll be some reaction stuff. Okay, we'll post it right after school today.